Good afternoon, everybody.
Hello.
Hey! How is everybody today?
Great.
Great, superb. Who's hungover?
No.
No. Chris is definitely hungover.
Is the camera on? No.
Excellent. So is this the last session or next to the last session? I think it's the last session.
No,
there's more. There's more.
There's more. There's more.
One more. Penultimate session.
Penultimate session. Sasha, your session is after this, and then we've got the Geek Speak as well.
Yeah.
Yes. With pizza and lots of fun discussions, and sometimes we can get Sasha to shut the fuck up. Not often, though.
Jim Moyle says that.
So we're going to talk a little bit about Atlantis Computing and Atlantis USX. Think outside the box. So we're going to talk a little bit about new features. I'm going to talk a little bit about some interesting large projects we've done. Feel free to stick your hand up, ask any questions you like during the session, that is fine. Alright.
Where is David gone?
Oh.
Who's too chicken?
Too chicken. Just a couple of interesting facts I want to take you through before we get to the meat. So 5 exabytes of information created between the dawn of civilization in 2003, but that much information is now created every 2 days. What was everybody doing before 2003? Being lazy. Enterprise data will grow 650% in the next 5 years. 2.5 exabytes of data was generated daily in 2012, and that number is doubling every month. World's information doubles every 1.5 years. And by 2020, IT departments will need to manage 10 extra servers, 50 extra data, 75 extra files, and all with only 1.5 extra people. I've showed this slide before, and the most common things that happen when I show this is somebody sticks hand up, says actually we've been downsized, so that's 0.75 now.
Extra one for you.
Go on.
How much of it is crap information?
I don't think that matters. because if you tell a story, somebody who's managing storage, it's like, can you just sort through this and tell me which stuff is crap and which stuff is valid?
Jenny thought that was a slag off of the slide there. It was like, how much of this stat is crap? It's like, whoa, that's a bit heavy going for Sunday morning, isn't it? But it's Sunday afternoon and it was more the data types, so just carry on.
Thanks, Andy.
No worries. It's going well so far.
Good. I'm glad you think so. Anybody else think it's going all right so far? First 5 slides, we're settling into the presentation nicely. Good. Okay, number of connected devices is going to be 3 to 4 connected devices per person. 25 trillion by 2020. Amount of capacity needed, 40,000 exabytes by 2020. Amount of spend on IT. That doesn't look good, does it? There might be a small issue here. If you are looking at what you're going to do over the next 4 to 5 years in terms of storage, in terms of compute, this is the problem. We're all going to have to cope with this. Because we're going to have to do a lot more. And traditional ways of doing stuff, signing a big check to EMC or NetApp, is not going to help you out with this. We need to start thinking about doing stuff a little bit differently and a little bit more efficiently.
So, I think most people heard about Atlantis. Most people probably know the product we started with, Atlantis. Who knows what USX is? Yeah. All hands.
And you can put your hand up, you work for us.
That's right. I know about it.
Awesome, Andy.
So that's 3 now.
Who knows what hyperscale is? No, more hands. So the difference between the two, thank you very much. If we look at hyperscale, we could say it's convection. It's a small, medium, large, and you get a box which gives you all-flash performance at a very attractive price point, and we still give you the ability to avoid vendor lock-ins by choosing your own hardware. and your own hypervisor. And it's a scalable platform. But it's as simple as possible, small, medium, large, where USX could be seen as something tailored towards what you exactly need. So a handcrafted beer versus regular. But we'll talk about more of that later. Mythbusters, so there are some stories going on, especially when the vendors talk about us, and they will say stuff which is not necessarily true. So we'd like to do some myth busting, and maybe you guys have some more myths that we can bust. So happily want to hear those. So first of all, many people say Atlantis uses RAM and therefore my data isn't safe. We can use RAM. We can use RAM as a primary storage. It's a perfect use case for stateless VDI, but we can also leverage SSD or flash as an acceleration tier if you're running different workloads. So typically, if you'd be running your Oracle database on Atlantis storage, you would not do this in RAM. You would use a different acceleration tier. And we also have different options on how we handle this data. So if you want the absolute best performance, maybe for VDI, we have an option called fast sync, but we don't typically use this for database and server workloads. So this is absolutely not true. Your data is safe. Another thing people used to think is that you need an awesome amount of RAM if you want to use Atlantis. We do inline deduplication, which most people you know. So the difference in typically dedupe is done post-process. NetApp, for example, that runs a weekly process which looks at what data is unique, filters out the crap data, and helps you from a capacity point of view. That, however, does not help you from a performance point of view. Therefore, we do it inline, meaning that every data block coming in, analyzed real time, we look at, is this data unique or not? If it is not unique, we know that we've already safely stored it, and therefore we don't need to store it again. We can give an immediate commit back to the application. But this also means that we need less of the acceleration tier, because we only use it for the unique data. So my point would be that we need a bit of resource, but we don't need lots and lots and lots of those resources.
Compression. Compression.
Compression. Would you like to say something about compression, Andy?
Yeah, you could. No, I've just had a cough, mate. Where you going?
I think Andy wants to say something about compression. Do you want to say something about compression?
So if you're using certain architectures, you can add in compression as well as inline dedupe to further reduce the capacity taken of your data. That's something what? Yeah.
That's what my cough was all about.
Okay, perfect.
Okay.
Still doing very well so far.
Thanks for your input.
So next up, dedupe is a risk, right? Because you need to calculate what dedupe you think you'll be getting, and if this dedupe is worse than what you figured it would be, you might need more resource. First of all, we have lots of numbers that we typically see for specific workloads. But we have a tool called the dedupe estimator. It's a virtual machine that you can deploy in your own environment. You can point it read-only to a data store. It will analyze this data, and it will give you an exact number of what the dedupe will be on your data. So you don't necessarily need to believe me, Jim, or Andy if we say that we will get you a certain dedupe number. We can prove it in your environment, produce a nice report about it, and therefore de-risk the project because you know exactly what the dedupe will be.
So this is really interesting, right? Because there's a number of, particularly Extreme IO are very bad at this, right? Because they've got a very expensive box, their business case is reliant on getting a very good dedupe ratio. Because what people don't realize, it's fairly easy math, but what people don't realize, if you build your business case on a 90% dedupe ratio for your XenApp, your VDI environment, and you don't achieve that for whatever reason, and you only get 80%, well, the difference between 90 and 80%, no, that's not a big deal, right? It's a massive deal, because now you actually need to double the amount of boxes you buy, right? Because you've actually doubled the amount of unique data that you have to cope with in your environment. So be very, very careful about people who make their business case on a promised extremely high level of deduplication. Because if you don't achieve that, you're in the shit. So that's why I like the dedupe estimator tool that we provide, because you can run it against existing data, you can run it against existing environments, and you can tell and you can size correctly for the amount of unique data you have in your environment.
Absolutely. So People also think we are a one-trick pony. You only need us for VDI. You only need us for extreme performance. That used to be true until 2 years ago. But with our USX and hyperscale platform, we can accelerate and optimize any workload that you run in your data center. We have options to make it highly available, or 0 RTO, RPO. So this is definitely the biggest myth that we need to bust. Obviously, we have a very good track record in VDI. We do well in VDI, but we can do much, much more.
I was hoping Julian was going to be in the room for this very next point, and he's just arrived through the door, so that's very good timing. Thank you very much. So last point is you need to be an expert to set this up. You need to speak to me, Andy, Remko, and you need a lot of knowledge to do this. This is not true. How long does it take you to do a proof of concept, Julian?
Maybe half an hour maybe, you know, if everything's okay, if you have your images downloaded, so it's very, very easy.
Look at that. Perfect.
Right. Thank you very much.
I mean, obviously, if Julian can do it, anybody else can do it.
Absolutely, yeah. Absolutely.
In 15. Okay, I'll do this one. So let's look a bit of the architecture. So USX is the platform and the engine, not only for USX but for hyperscale as well. So USX is the engine. Hyperscale is a bundled solution of USX and certain types of hardware. But if you look at what we do, on the bottom is the storage layer. So we take in a bit of capacity, which can be shared storage, which can be local storage. So hyper-converged, you know, the bus and what people are looking at. But many people have some today. So we'll talk about that later. We combine this with an acceleration tier, which can be RAM, it can be flash, it can be SSD. And out of that we form what we call a virtual volume, of which you can have multiple. And on a virtual volume we have our data services.
Don't forget your panda.
Yes, my panda is coming up. Well, I was hoping David would be here, because has anyone been to David Gone's session?
Yes.
He talked about a specific beast called the sand panda. And he talked about the sand panda only eating lungs and how you should get rid of this panda. It doesn't really have a purpose in life anymore. But there is a problem. Many of us have sand pandas in the data center, and many of us cannot get rid of this panda today. But maybe we need to optimize the performance of this panda. And we need to make it better performing. We need to make it have a better capacity. So pandas will be around for quite some time. And we can do hyperconverge, but we can also accelerate your SAN. We can accelerate your pandas.
There's no need to kill the panda?
Yes.
Oh, that's cute.
They are cute.
It's going to be just a little
Sound administrators have never struck me as cute before, but you know.
So we talked about the inline deduplication and compression. Stop listening. We also do caching, like many people. We think we do it a bit smarter. So most caches are first in, first out. But because we have knowledge of the data you're keeping, we can make sure that we keep the data that you request most often in our cache. Yeah. We do coalescing, which is gathering small IOPS into bigger chunks that we can write in one go to the underlying storage. We have some more services that we will talk later on, especially Stretch Cluster, which is a new feature in USX 3.1. And I think Jim is going to talk about VVol.
Yeah, I will talk about VVols later. In fact, now, look at that. Anybody had a good look at VVols in vSphere 6 yet? No? Yes, one. Okay. I think VVols are very cool, up to a point. Now, they enable you to do some interesting stuff, so effectively offloading snapshots to the underlying storage. And doing it in such a way that you do not encounter performance issues anymore with snapshots, because previously, if you took a snapshot, the VM would run off the delta disk, right? And then etc., all the way down the line. With VVols, that doesn't happen. Because you're relying on the underlying storage to recover to that snapshot point in time, you actually always continue using the main master image. So VMware say that you can run up to 32 snapshots on a single VM without any performance impact at all. And we would agree with that when you offload the recovery of that snapshot on a per VM level to the storage. You can also use vVols to tag VMs, saying this VM must be on a data store with this capabilities in terms of performance, in terms of resilience, etc., etc. So somebody can't come along and move that VM to a piece of storage that doesn't support those features that you tagged it as necessary. So again, making sure that your VMs, so somebody doesn't move SQL to a local crappy disk, yeah, and you suddenly run into massive trouble, they won't be allowed to do it. Two brilliant things, excellent. If there are any issues with vVols, sort of. Currently, vVols you cannot integrate with SRM, and also even though you can do vSphere level replication on them, you cannot offload the replication to storage. Now, obviously, these two things will be fixed very, very shortly, seeing as this is the first implementation of vVols, but just to bear that in mind if you want to implement them. But, next slide please. vVols are very cool. And you will get vendors who come out and say, yes, our new stuff has vVols, but it's probably unlikely that they're going to backport it, right? If you want to enable these kind of very cool vSphere level features for any storage in your environment, all you need to do is front it with us. And we will enable vVols and surface those capabilities up to the hypervisor and enable you to do it across your entire environment if you wish to make that kind of investment in technology.
Right, so Jim talked a bit about snapshots. So in USX3 we have two possibilities for snapshots. We have volume level snapshots and we have VM snapshots. So if you're using the vVol capability, this means that we can dedupe snapshots when you make them in vCenter. And obviously we will dedupe volume level snapshot as you take them from USX. There is a big advantage of the snapshot taking less space, but especially we can improve the performance with snapshots. So if you look at how we do this, typically when we take a snapshot, a read becomes many reads and a write becomes 2 to 4 writes plus 2 reads. So this means that there is a big performance penalty when you're using snapshots, right? We do this differently. So instead of the typical copy on write, we are using redirect on write, which basically makes it 50% more efficient. So apart from the usual acceleration we do, we can give you an extra benefit by using a smarter technology that you can use transparently. So you take snapshots as you are used to taking snapshots. And we will optimize and offload this.
So just to be clear, this is snapshots on a per volume level. If you're going to do snapshots on a VM level, you need vVols.
Yes. There's some more detail on how it works. So look, if you want to go into the details, look in the slides. Key takeaway, if you compare the copy on write, is that we will take many writes and many reads, so there is a multiplication, amplification. With Atlantis technology, we require one read and only one write, reducing a 50% reduce of the overhead.
I was just saying, just looking at that slide going, I did forget to change the font on that title. Yes, so it would fit. Yeah, it's probably the beamer. It's fine.
So let's talk pandas again. I did a project recently in the Netherlands. There was a local government together with a province in the Netherlands, and they wanted a dual data center. They were looking to get their RTO and RPO as low as you can. Obviously, everyone likes it to be 0. So their first question was, can we please have 2 of those pandas, one in each data center, with replication in between? And we had to think about what can we do here. And the answer was that with our stretch cluster technology, we can optimize this. So we can immediately get rid of one of the pandas, right? And in fact, we can get rid of the pandas at all. And their question was originally, we want 211 terabytes of data, and if you do this with pandas, you will need it twice. So you will have 211 terabytes in your first data center, 211 in the other. and you need replication. It's a complex technology. So if you look at how we solved this particular project, we took local storage, so we went for hyperconverged, using SSD as an acceleration tier, and we're using SAS for the capacity tier. And we were able to fit this 211 terabyte in 160 terabyte of local SAS storage, redundant over 2 data centers. So this means that we can lose half of anything in your cluster, which could be a data center. It could also be half of this data center and half of that data center. And we'll still give you the availability to your data. And the end result is an active-active cluster, so they can run workloads in one side, they can run workloads in the other side. Sasha?
Far they are from each other.
8 milliseconds.
Yeah,
So-
how far
So it's essentially it's latency that we need to look at as a key measure. If you're looking at that in terms of distance, it's about 100 miles usually. But if your network shit, it'll need to be smaller.
The question is, we have almost the same setup without Atlantis, isn't it? The question is, okay, we still not use it like one data center. We use it like twin head data center.
So it's more active passive.
Okay, the question is, okay, they say that the distance is a problem, yeah? And that the question is how far it's away.
Yeah, so you're writing deduplicated data to both sides, right?
Thank you.
Yeah. Now the key here is post dedupe, so dedupe's in line, so you don't have to write it then dedupe it. So the amount of traffic that you're chucking across is much less. But you have to wait for the acknowledgement from both sides before you can go back to the workload and say, yes, we've definitely got that block of data, right? So if there's no reason you couldn't do this over something that's much more latent, but you'd kill your performance because you have to wait for the block to be acknowledged from both sides. So hence the limitation on latency between the two and distance between the two locations.
So inline dedupe is again a key enabler here, because any data coming in that is not unique never needs to travel the network. We do not need to wait till it's acknowledged on both sides. It can be acknowledged immediately because we have already stored it safely, and we know this. We just update our metadata, and that's it. So this means that the replication going on inside this cluster is dedupe aware, which means that if your dedupe is, for instance, 70%, in this particular project it was 78% on average. So we took all of their workloads, which was Oracle, SQL, file services, documents, all kinds of data. So we made assumptions around the dedupe being around 70%. It was actually a bit better, but it means that 78% of this data never needs to travel between these two sites. So that is a huge advantage. So as Jim said, requirement is most specifically around the round trip. We're stating that it could be 100 miles at this moment, but I think distance is less important than the round trip. Yeah. Obviously, we need to protect against split brain scenarios. So if the network lines, which you should probably want to have redundant, are failing, then we need to decide which of those two sites will continue to operate. And therefore we leverage a tiebreaker, which will typically be in a third physical location with independent connections to both of the sites.
Yeah, and that's just a VM, so that could even be a cloud location, it's no problem, right?
Guys, could your storage profile be totally different on both sides, or does it have to be the same because it's clustering?
So what do you mean by your storage
physical
profile?
storage, so the physical storage underneath.
No, so that can be very different, right? So this could be total commodity hardware. This could be looking back at HP local disk. That could be Dell and whatever. So you can do it on heterogeneous hardware, no problem. And remember, there's no SAM involved, no shared storage involved in here at all. This is just local hyperconverged split across two locations.
Nice thing for me personally is that we won a Best of VMworld with this particular project, which was the third time in 4 years for Atlantis, if I'm correct. This one was a bit more special for me as it was one of the projects I was involved in. It was very nice.
We're going to get him a badge later.
Yeah. But best of the other hypervisor thing world. Okay. Any more questions about stretch cluster before we move on?
So, I'm going to talk now about a very interesting project that we are currently embroiled in. We mentioned before the two sort of sides of deploying USX. So hyperscale comes as a physical appliance, is pre-configured, you just rack it up and walk away, that's all fine. For very large or very complicated deployments, I would always say use the software option, right? Because if you've got big stuff to do and you need to tune it carefully, then you need the options to do so. And effectively trying to de-risk your project by using USX as your storage, and we'll show you why that is in a second. But we can do a whole bunch of stuff with different architectures around the sort of central file system, which is the key of our technology, and just deploying it in slightly different ways to get some very different results. So, what was the project? There's a big financial VDI. They also have ZenApp, but that's not included in this. So this is Zen Desktop, 71,000 users, stateless. Hypervisor is v655. App delivery is by app v or app volumes, depending on which is the best use case. I.e., do they need isolation or not? If they need isolation, it's app v. If they don't, it's app volumes. And USX underpins all of that. What's the requirements? It needs to be scalable, so as they ramp up from a couple of thousand users to 70,000 users, everything needs to stay the same in terms of performance, everything needs to stay the same in terms of configuration, etc., etc. So they've opted for a pod design, very sensible given the number of users, right? Because you don't get management consoles that scale to this amount of VMs, this amount of users, etc., etc. They're obviously going to have a lot of racks of gear, of blades, to accommodate this amount of users. But they want each rack to be effectively independent of all of their other infrastructure. So the only traffic leaving that rack effectively should be HDX traffic. Now there's always going to be like management consoles and automation and stuff going on as well, and we're never going to get to a stage where the only network traffic leaving the rack is HDX, but that's the goal, yeah? So if you lose most of your data center, there isn't the dependencies on shared infrastructure between racks that would take your entire environment down. And so that reduces their failure domain to one rack, effectively. And that's what they like about, that's what they're aiming for. It needs to be highly performant, and it must be automated. They do not want to run this with 3,000 people. So every single product in this stack must be able to be automated. When we looked at the original set of products for this project, we had to eliminate like half of them immediately, just because they didn't have API access, because they didn't have proper PowerShell, and that means that there's no way they could get into this solution. So, what the blades, individual blades look like, a couple of 600 gig 10K SAS drives, half a terabyte RAM, a couple of processors, and those local crap spindles are just being used for what we call snap code, which is when you're running a stateless environment, it will run 4 AM and just take a copy of the VMs. And in stateless environment, this is fine, right? Because when you reboot, you've thrown all of that stuff away. You just need the VMs, and in this case, it's PBS that they're using. Will then re-download the image, and as long as you've got the VMs, you don't care about the data. So that's to bring the VMs back in case of any failure. And we're using RAM to accelerate in this case. I think it's 120 gigs of RAM on our simple memory appliance, and the rest of it is given over to desktops. They're going to get, or they're aiming for about 80 desktops per blade. And their desktops come in small, medium, large size, and they don't want to worry about where to place them. So we've got DRS to place them across the cluster, and everything works fine. So that's fine for your desktop VMs. If you want to have nothing outside of the rack, that has got dependencies, you're going to need to put all your infrastructure in here as well, right? So you're going to need to put your PBS service, you're going to need to put a vCenter in here, you're going to need to put SCCM, etc., app V, app volumes, all of that needs to go in rack as well. And there's no storage in here apart from local storage on blades. So there's no SAN in the rack. Yeah. What we've done is we've taken 2 out of the 16 blades per blade chassis and given those over to management. I was just explaining the RAM and the snap-down stuff, which I just went through, so we'll not bother too much about that. So this is the management plot I was talking about. So this is one rack, is 3 blade chassis. One blade chassis will do about 1,000 users. So this is 3,000 users. So this is one rack, 3,000 users. They've got 71,000 to get to, so there's going to be a few of these, right? They're spread across the world. So what we've done is we've used USX in stateless RAM configuration to accelerate the desktops. And what we've done is we've taken 6 blades out, and what we've done is provide a hyper-converged infrastructure across chassis. And that means that you can lose a chassis and everything will still run, because you've got, in this case, we've got N+2. So that means that within the rack, everything is redundant and per chassis basis in terms of management infrastructure. And you've got east-west communication, so you don't actually have to go out of rack for networking either. So this is really cool because instead of local SAS disks, we've now just swapped them out with a 1.2 terabyte, 1.6 terabyte SSDs in mode 1. And that means that we're getting enough capacity to do all the PBS servers, SCCM distribution points, app volumes, app stacks, etc., etc. Giving them that independent of any other infrastructure architecture, which I think is quite cool, right? All local storage, all infrastructure, all desktops, no SAN, completely scalable. Wow, that was good. Took me a while to do all that, that's fine. They came up not so long ago, maybe 6 weeks. Jim, we've got a tactical solution we need you to help me with. Okay? Well, tactical, that should be fairly easy, right? Yeah, we've got these other desktops. We haven't really talked to you about those yet. Okay. I thought 71,000 was probably, all of them. But no. So we got some more desktops. We got 14,000 persistent desktops that we're running.
Somebody walked around and found some else. We forgot.
It's quite tactical, 14,000.
Yeah, tactical 14,000 users. Yeah. They will be moving on to this solution, the stateless solution, but they're not due to be moved till the end of the project, so probably a couple of years down the line, right? They're currently sitting on NetApp, and this is obviously a global organization. So what's happening is that they cannot find a time slice during a 24-hour period to run DG, yeah, without severely impacting some part of the world in terms of performance. So I said, can you do anything about that? Yes, probably. Now they've got an ELA, so they could turn around to us and say, stick it in. Fine. So in this case, what they want us to do is to replace the DG upon NetApp with RDG, because it's inline, not post-process, so you don't have the performance impact, and also raise the general performance of storage of this NetApp storage by fronting it with USX. Yeah, so we've used a simple hybrid model, which is effectively taking some local resources, in this case it's RAM, to accelerate the shared storage, which is NetApp, right? And then effectively, the only thing you have to do to enable this after you put it in is storage vMotion those persistent desktops into our data store, and that's you done in terms of optimization. There's no drivers or agents or anything like that you've got to muck about in Windows. You just move into the data store and you're done.
A simple hybrid?
It is simple hybrid. There is, I would have actually picked fooled for this,
Yeah.
but there were internal political reasons, which I'm not going to go into because they're very boring, as to why simple hybrid was chosen in this particular instance. In some ways, it's not the technology that's been the problem, it's been the fact you're dealing with a massive, massive, massive organisation. It's politically tricky to do, but anyway. So this is now the third way we've solved a different problem with USX inside this custom, right? So we've got the RAM for the stateless desktops, we've got the Hyperconverged for the infrastructure, and then we're accelerating some of their shared storage as well.
Something I often see in projects as well is that everybody has probably a mix, right? You have stateless and you have persistent. You want most to be stateless, but you need to have some persistent. And when you start a project, you're never sure if it's going to be 80-20, 70-30, or any other split, right? So one of the things I often tell to customers I'm talking to is if you design this on hyperconverged infrastructure, you can use in memory, or you can use the SAS disk that you have for the capacity, or use an SSD for the acceleration. And this means that you can run the same configuration, same hardware, same license, same software, and it doesn't matter if it will be 80-20, 70-30, or anything else. In the project, if you move in the project, sometimes you need to reevaluate decisions, or more of this, less of that, and you can de-risk your project by knowing that the architecture you're choosing is flexible enough to change these parameters.
And then a couple of weeks ago, I came to me, so we got some other stuff we've got to talk to you about, Jim. Oh God. Okay, what now? So well, we've got like 6,000 apps we need to remediate and get into a stateless, get into the stateless architecture. I'm like, yeah, how are you doing with that? Because that sounds hard to me. They're not doing very well with that. They've got about 50% of where they need to get to hit their milestones. So what they're doing is they're doing app V and doing app volumes where it's really simple to do at the app, and it takes them a very small amount of time. And any application that's tricky, needs any kind of capacity on the local drive, temp files, etc., or anybody that needs to install our applications, what they're doing is temporarily elevating it privileges for people and then letting them install stuff and then taking them down. That's a great security plan, but anyway. That's what they're having to do to try and hit their milestones. They do not want to do persistent because they're trying to get rid of persistent, and they don't want to put persistent in as part of this architecture. So their solution for this is app volumes, writable volumes. So effectively VMDK in this case attached via the hypervisor. That is applied at logon in this case, and that VMDK follows these around with their own installed applications or departmental installed applications that need local drive persistence. So they said they need a RPO of 15 minutes for this, for those VMDKs, and they need it to cross 2 data centers for resilience, and they don't want to do persistent. The problem here is the RPO of 15 minutes, right? Because even though this is a tiny amount of users, it's 7,000 users that they estimate are going to be in this bucket. Yeah, so it's only 10%, but 7,000 VMDKs knocking around is still, and they're going to be 100 gig in size each, so 7,000 times 100 gig, you can see that it's a significant. And if you've got an RPO of 15 minutes for 2 data centers, you cannot do this with async. You cannot do this with asynchronous replication, because your replication would have had to have finished before your 15-minute slot ends to achieve your RPO of 15 minutes. So what do we do? To the ratio comes metro cluster, stretch cluster, right? So what we can do is copy what Remko did for the customer in the Netherlands and put a stretch cluster across 2 data centers underneath these app volumes, writable volumes. So now, as their requirements have changed, as the project milestones have got quicker, as they know what they're doing a little bit more, as more facts come out, it means that they've had to be more demanding of us in terms of what can you do for us. And it's been really nice to be able to say, yeah, we can handle that. We can take that use case, we can take that new requirement, and we can provide a good solution for you underneath it. And you don't have to go and buy any SAN at all. This is everything here is all on local disk. Yeah, including the stretch cluster across underneath these VMDKs. So, that's what I mean about being able to de-risk your projects, because if you do have something that comes up, and we all have this in all our projects, right? You know, 3 weeks before the end, somebody goes, oh, we need that. And we never architected for that. We never priced for that, we never sized for that. But all of a sudden it's a business requirement that we must have, that need has to be met. And using a software-based solution that is able to do all of this stuff means that you can go, yeah, no problem, we'll take care of that, it's all right. And that's what I mean about de-risking your project by using USFs.
Another nice one is that there is no specific extra license for functionality. So you buy one license and it's all in there. There is no expensive Metro cluster license. There is no extra license for persistent or stateless. It's one license. There is no license for shared local. It's one license. So if your requirements change, you can do this within same software, same license. A bit more than small users.
Yeah. Does anybody have any questions on the project or the configuration or what you can do? No? Excellent. Well, thank you very much for coming along this afternoon.